Assalamualaikum. Hi, my name is Muhammad Iman bin Abdul Muin. My metric number is 303-898.
Now I'm going to answer question 1. Given Q star equals to E plus F times A plus E plus CPS minus DPC plus GPI, all divided by F plus B and then minus GPI, where A, B, C, D, E, F, G are more than 0. For question A1, so for this one, we need to partially differentiate Q star with respect to PS. So we need to focus on CPS and denominator remains constant. So when we differentiate, we get FC divided by F plus B. For 2 Roman, we need to refer the answer from 1 Roman. We need to state the direction relationship between Q star and PS. Since FCB more than 0, then the whole expression is positive. Means there is positive relationship between Q star and PS. For 3 Roman, when we need to explain the effect of change in PS on Q star as the price of substitute a good is increased, consumers will tend to buy this product instead, which is Q star, because it will become relatively cheaper. As a result, the demand for product Q star will increase. So, an increase in PS will increase Q star, showing a positive substitution effects.
Assalamualaikum. My name is Muhammad Harid Saifullah bin Sofian with the matrix number of 303-928. From this question, we are given two equilibrium conditions. For the first one is the demand function, which is Q star equal D P star Y, where demand decrease as price increase and demand increase with higher income. And for the second equilibrium condition, for the supply function is Q star equal S P star R, where supply increase as the price increase and supply decrease if input price R rises. Now we have to rewrite it in implicit form. To apply the implicit function theorem, we have to express the system as shown. Then we have to know the condition of the implicit function theorem. The theorem requires two key conditions. First, continuous differentiability. The function d p star y and s p star r must be continuously differentiable. Given that the problem states that the partial derivative for dp, dy, sp, and sr exist and have well-defined signs, so we assume smoothness. For the second one is non-singular Jacobian at equilibrium. The Jacobian matrix of the system with respect to the homogeneous variables, which is Q star and P star, must have a non-zero determinant. Then we will have to construct the Jacobian matrix. The Jacobian matrix J is formed by taking partial derivative of F1 and F2 with respect to Q star and P star. With the equation of Jacobian matrix that I have shown here, the first column is the derivative of Q star, while second column is derivative of P star. Then we have to check if it is non-singularity or not. So the determinant that we have got here is dp minus sp. So what is the economic interpretation of this determinant? dp minus 0 means demand slope downward. sp more than 0 means supply slopes upward. So negative minus positive, we will get negative. means since the determinant is non-zero, the Jacobian is invertible at equilibrium, meaning the system is locally solvable for Q star and P star as function of y and r. So we know that both of conditions of the implicit function theorem are satisfied. Therefore, we can proceed with comparative statistics to analyze how changes in income or input price can affect equilibrium price and quantity, which is the focus of part 2.
Assalamualaikum warahmatullahi wabarakatuh, and hi. My name is Siti Salwa binti Manawi Cik Mi, and my metric number is 303806.
So right now I would like to explain about question 2 Roman, which is the question is analyze the effect of an increase in the income Y on the equilibrium quantity and price of the good in the market. First of all, we have our equilibrium model, which is F1 is Q star equals to D in bracket P star and Y. And then the F2, which is the Q star equals to S in the bracket P star and R. And for the equation also, we have here the assumption that dP star is less than 0 and dy is more than 0. And then we have the SP star more than 0, and then SR is also more than 0. But then also we have to make the equilibrium system, which is equal to F1 in the bracket Q star P star and Y equals to Q star minus D in the bracket P star and Y equals to 0. And the F2 equilibrium system, which is F2 in the bracket Q star P star and then R equals to Q star minus S in the bracket P star and R equals to 0. So for the first step, we need to set up the total derivative system, which is we must find the effect of a change in Y or income on the equilibrium Q star and P star. First of all, we need to do is we put the dQ star divided by dy equals to the equation, which is Q star minus D in the bracket, which is the P star and Y, and equals to 0. And then we must do the first equation, which is the dQ star divided by dy minus dP and the dP star over dy minus dy equals to 0. So this is basically our first equation. And then we do need to do our second equation, which is dP star over dy equals to Q star minus S P star and R equal to 0. And then we need to do the second equation, which is the dQ star over dy minus SP dP star over dy equals to 0. Next, we must do the step second, which is we must solve the equation system of equations right just now. Now we want to turn the second equation into the third, so we must do the dQ star divided by dy minus SP dP star divided by dy equals to 0. And then we must do the third equation, because we want to change the second equation to the third equation, which is dQ star divided by dy equals to SP dP star divided by dy. The SP equation became positive because we moved it from the left to the right side. And then we need to insert the third equation into the first equation, which is it will be SP dP star divided by dy minus dP dP star divided by dy minus dy equals to 0. So this equation we already insert into the first equation, and then we must put the dy on the right side. So it became SP minus dP in the bracket dP star divided by dy equals to dy. And then we must solve for the dP star divided by dy, which is will be dP star divided by dy equals to dy divided by SP and dP. It is because we move the SP, move the SPDP under this equation, and then we use the third equation to get the dq star over dy. So dq star over dy will be equal to SP times dy over SP minus dp. So then when we get both of the answer for dp star and dy, and also dq star over dy, we must do the third step, which is the assumption. Just now we see the assumption is dp is less than 0, dy is more than 0, and sp will be more than 0, which is where sp minus dp will be more than 0, and when the addition negative plus 0, because when negative meet negative, it will be positive, and then we will get the result for this equation. dp star over dy will be over than 0, and then dq star over dy will be equal than 0. Then the answer will be demand curve will shift to the right because of higher income level that will cause upward pressure on both price and quantity. That's all for me. Thank you.
My name is Adam Saufi bin Saiful Shafi, and my number matrix is 303934, and I'll be talking about question 3 from assignment A3.
Given Cobb-Douglas function Q equal to K 0.4 L 0.6, we just need to find marginal product capital, which is dQ over dK, and we will get 0.4 K negative 0.6 L power 0.4. For MPL, marginal product of level, we just need to do dQ over dL, and we will get 0.6 K to the power 0.4 and L power negative 0.6. For APK, which is average product capital, we just need to divide Q divided by K, and we will get K negative power negative 0.6 and L power 0.4. For APL, average product labor, we just need to do Q over L, and we will get K 0.4 L to the power negative 0.6. For E, 0.4 is capital elasticity. What does it mean? It means 1% increase in capital, output will be increased by 0.4%. For 0.6 is labor elasticity. It is mean 1% increase in labor, output will increase by 0.6%.